The propagation modes of coaxial waveguide are solved in this tutorial. The electromagnetic fields and the propagation constants are obtained. A new project is created first. Create a new project. Click the File tab and select New Project. Set up the analysis space as follows. Model unit millimeter. Analysis space 2D. Thickness in depth direction 1 mm. Click OK button. The initial setting has been done. Let's create two circles for inner body and air body. On the Model tab, click Sheet Body and select Circle on the submenu. Designate the center point. In the Parameter Input dialog box, enter center point x0, y0, z0, and click Next button. Set the radius. Enter radius 3 and click Complete button. Now that we have created one circle, create another. Designate the center point. In the Parameter Input dialog box, enter center point x0, y0, z0, and click Next button. Set the radius. Enter radius 1 and click Complete button. Finally, click Exit button and exit from the dialog. Two circles have been created. We set the analysis conditions. On the Model tab, click Analysis Condition. The Analysis Condition Setting dialog will show up. On the Solver tab, select Electromagnetic Analysis Hertz. Go to the Electromagnetic Analysis tab. Select Waveguide Analysis at Analysis Type. Go to the Waveguide Analysis tab and set up as follows. Minimum frequency 1 GHz. Maximum frequency 1 GHz. Go to the Mesh tab. Set reference frequency 1 GHz. Click OK button. The analysis conditions have been set. We assign names to the body attributes and the material properties. Highlight the inner circle on the modeling window and click to select. On the right-click menu, click Body Attribute/Material Property. In the Body Attribute/Material Property Setting dialog box, enter Body Attribute Name Inner. Select 02_metal on Material DB and select Material Name 003_AG and click OK button. Highlight the outer circle in the modeling window and click to select. On the right-click menu, click Body Attribute/Material Property. In the Body Attribute/Material Property Setting dialog box, enter Body Attribute Name Air. Select 01_fluid on the Material DB and select Material Name 000_air and click OK button. The body attributes and the material properties have been set. A line for the integral path is created. On the Model tab, click Line. Designate the start point. In the Parameter Input dialog box, enter start point x0, y0, z1 and click Next button. Designate the endpoint. In the Parameter Input dialog box, enter endpoint x0, y0, z3 and click Complete button. Finally, click Exit button and exit from the dialog. A line for the integral path has been created. We set the boundary condition for the integral path and also set the outer boundary. On the Model tab, click Select Edge on the drop-down list at Switch Object. First, select the integral path. On the right-click menu, select Boundary Condition. In the Boundary Condition dialog box, enter Boundary Condition Name, Integ, and click Edit Data. In the Edit Boundary Condition dialog box, go to the Electric tab. Set Boundary Condition Type, Integral Path, and click OK button. Then click OK button to exit the Boundary Condition dialog box. We set the outer boundary condition. On the Model tab, click Outer Boundary Condition. In the Edit Boundary Condition dialog box, go to the Electric tab and confirm that the boundary condition type is electric wall. Then click OK button. Now the outer boundary condition is confirmed to be electric wall. Run the mesher and the solver. On the Model tab, click Analysis Condition. The Analysis Condition Setting dialog box will show up. Click the Mesh tab. Deselect Set the general mesh size automatically and set the general mesh size to 0.2. And click OK button. On the Model tab, click Run Mesher/Solver. The calculation will start. The Calculation Finished dialog box will show up when the calculation finishes. Select Show Field and deselect Show Table and click Show button. The screen will change to Results window, and the meshing result will show up. The Frequency and Propagation Constant dialog box will appear too. The calculation results are available in various formats. Let's see the field vectors and some graphs and charts. Let's see the electric field vectors. On the Results tab, click Element Vector. The electric field vectors will show up. You can check the distribution of the electric field radially between the center conductor and the external conductor, which is unique to coaxial cables. Let's see the magnetic field vectors. With Element Vector activated, on the Results tab, select Magnetic Field on the drop-down list of field. The magnetic field vectors will show up. You can check the magnetic field distribution in the circumferential direction, which is unique to coaxial cables. Finally, save the project. Click the File tab and select Save Project As. Enter the file name and the location in the Save As dialog box, and save it. Saving allows you to launch Femtet at a later date, open the project, and review the model and analysis results. That's it for the Electromagnetic 2D Waveguide Analysis tutorial video. See the tutorial topics in the Femtet help for more information. Thank you for watching until the end.